So in this problem, it's given here that tangent of alpha equals P over Q. And alpha equals 6 times beta. Alpha is an acute angle. We need to show that half of P cosecant of 2 beta minus Q times secant of 2 beta equals square root of P squared plus Q squared. Let us begin. So here we will start with the given value of the tangent function. So we have tangent of alpha, so that's equals to P over Q. If we know the value of tangent alpha, from here we can also find out the value of sine alpha as well as cosine alpha. So let's do that. For this, what we'll do, we'll construct a right angle triangle and consider this acute angle to be alpha. Then we know that this is going to be the perpendicular, then we have the base and the hypotenuse. Since it's given here that the tangent alpha is P over Q, so that means we will consider the perpendicular to be P and then our base will be Q, which means that our hypotenuse by using the Pythagoras theorem must be equals to P squared plus Q squared, and we'll have to take the square root. Now that we have all the three sides, we can find out the value of sine alpha. So sine alpha will be P over hypotenuse, which will be equals to, we have P, so that stays as P, and H will be square root of P squared plus Q squared. So when we cross multiply, then P comes out to be equals to square root of P squared plus Q squared multiplied to sine alpha. Similarly, we can find out the value of cosine alpha as well. So cosine alpha will be the base over the hypotenuse. So here base is given by Q. So we have Q over square root of P squared plus Q squared, such that the value of Q comes out to be square root of P squared plus Q squared times cosine of angle alpha. Fine. So we'll be using this value. Now let's start from the left hand side of the given problem. So we have half multiplied to P times cosecant of 2 beta minus Q times secant of 2 beta. Now we know that the cosecant and secant are the reciprocal of the sine and the cosine function respectively. So we have half multiplied to, so cosecant of 2 beta will become 1 over sine of 2 beta minus we have Q times secant of 2 beta. If we take the reciprocal, we have Q over cosine of 2 beta. Right. So this will be equals to half multiplied to, now we can replace the value of P with square root of P squared plus Q squared multiplied to sine alpha divided by sine 2 beta minus Q will be replaced with square root of P squared plus Q squared times cosine alpha whole divided by, so we have cosine of 2 beta. Now from both the two terms, we can pull out square root of P squared plus Q squared because that will be the common factor. Now we have square root of P squared plus Q squared divided by 2, and that will get multiplied to sine alpha over sine 2 beta minus cosine alpha over cosine of 2 beta. This will give us square root of P squared plus Q squared whole divided by 2 multiplied to, so let's combine the two fractions. So the common denominator will be sine 2 beta multiplied to cosine 2 beta, and in the numerator we have sine of alpha times cosine of 2 beta minus cosine of alpha times sine of 2 beta. Fine. Now what we have is a standard formula. Now here we have square root of P squared plus Q squared. Now sine alpha, what we can do, we can take this 2 and multiply with sine 2 beta cosine 2 beta, then this will become 1. The reason why we're doing this will become evident in a moment. Let's talk about the numerator first. We have sine alpha times cosine 2 beta minus cosine alpha times sine 2 beta, so that's nothing but sine of alpha minus 2 beta. That's a standard formula. Whole divided by, now we have 2 times sine of angle 2 beta times cosine of the angle 2 beta, which will give us sine of 2 times the angle 2 beta. Okay, so let's further simplify. We have square root of P squared plus Q squared multiplied to sine of alpha minus 2 beta divided by sine of angle 4 beta. However, we are given with the relation. We have the relation that alpha equals to 6 times beta, which implies that alpha minus 2 beta will be simply equals to 4 beta. Now that means we have square root of p squared plus q squared multiplied to sine of the angle. So alpha minus 2 beta will become 4 beta, and in the denominator we have sine 4 beta. So we can factor out sine 4 beta, and this gives us the expression on the right hand side, which is square root of p squared plus q squared. Hence we have successfully showed that the left hand side of the given expression equals the right hand side, with the condition that tangent of alpha is given by p over q and alpha equals 6 times beta, with alpha being an acute angle.